Hi, everyone. Today we're going to be beginning our notes on topic 7, which is properties of exponents and polynomials. In this unit, we will cover properties of exponents, vocabulary or classifying polynomials, adding and subtracting polynomials, multiplying polynomials, factoring polynomials or finding the GCF, and then factoring quadratic trinomials with the leading coefficient of 1. Let's begin on page 2, which is our introduction into properties of exponents. I want to begin with just what is an exponent. Here we see this expression, 2 to the power of 5. In this expression, this 2 is the base, and the 5 is our exponent. We use exponents to indicate repeated multiplication. So what this means is we have 2 times itself 5 times. Or in other words, 2 times 2 times 2 times 2 times 2. When there's a number in front, the only difference now is that we have a coefficient. That's the number in front of that base. So again, that base is here, x, that can be a variable. And then our exponent is a number. And that tells us how many times are we multiplying that base by itself. So in this example, the coefficient would just be that number out in front, 4. And then we multiply our base by the number of times, by itself, the number of times in the exponent. So we have x times x, or x times itself 2 times. On the TI Inspire, the exponent button looks like this, and it's located just to the left of the 4 on your calculator. So if we take a look at the Inspire, the exponent button is right over here next to where it says x squared. It's this little caret button. And I don't have any base in here, so it's just going to take the last answer. Okay, so let's go ahead and use the Inspire to evaluate 7 to the 4th power. So in the Inspire, I'm going to hit 7, and then to get up in my exponent, I'm going to hit that button. And we're going to see that takes us up into the exponent spot. We're going to hit 4, and then enter. And it evaluates to 2,401. Let's go ahead and fill that in. We know that 7 to the 4th can be rewritten. We can expand that into 7 times itself 4 times, and we get 2,401. You may or may not have learned these rules already in a previous class, but either way, go ahead and follow the directions below and only use the calculator to complete these following problems. So for example, for the first question, we have x to the 3rd times x to the 4th. You can go ahead and plug that into your Inspire by hitting x, the little exponent button, to the 3rd. Use your arrow key to get out of the exponent. Then hit times, and then we're going to do x to the 4th. So x, exponent, 4th. We're going to hit enter, and that's going to simplify the expression to x to the 7th. So let's go back and go ahead and fill that in. X to the 7th. We'll do one more. Number 2, y squared, or y to the 2nd power, times y to the 7th. So we're going to do y, exponent, 2. You can also use that x squared key. So actually, I'll show you how to do that. So suppose I didn't hit that exponent in 2, you could just hit this x squared, and it's just going to put a 2 right in the exponent for you. And then times y to the 7th, enter. And we get y to the 9th. All right. Go ahead and pause the video and fill in the rest of those and unpause when you're ready to check your work. All right, go ahead and check your work. So you might have noticed a pattern amongst all of these. The only thing to note is that for numbers 8 and 9, we cannot combine these into a single term because we have unlike bases. So if you notice the pattern, when we multiply powers of the same base, we add the exponents. So therefore, a to the 10th times a to the 3rd, these have the same base, so I can rewrite this as a to the 10 plus 3, adding the exponents, and it simplifies to a to the 13th. Okay, let's try a few more. On the next page, again, go ahead and just use your Inspire for this one, even if you've seen it before. We'll try a couple together. So for number 10, we have m to the 8th over m to the 3rd. To do this in the Inspire, I always like to do my fraction bar first, so I'll hit Control and Divide to get that fraction bar, and then I'm going to do m to the power 8, and then to get in the denominator, I'm going to hit the down arrow until I'm in the denominator, and then m to the 3rd, using that exponent key. Hitting enter, we have a simplified form m to the fifth. Let's do one more. We have n to the sixth divided by n squared. So again, I'm going to hit Control Divide to get that fraction bar. And our variable n, so n to the sixth, over, using the down arrow. And I'm going to do n squared, but now I'm going to hit that squared key. Just a little bit quicker. And I'll hit enter, and we have n to the fourth. So again, go ahead and pause the video and complete numbers 12 through 18 and see if you recognize a pattern. Unpause the video to check your work. All right, go ahead and check your work. A couple things I want to note about these. Number 12, 17, and 18 cannot be combined because we do not have like bases. These variables are not the same. The only other thing I want to note is number 14 simplifies to r to the first power, which you can just write as r. Did you notice a pattern? When we divide powers of the same base, we subtract the exponents. So in this example, a to the 10th divided by 8 cubed, we have a to the 10 minus 3, which we can do because we have the same base. And then 10 minus 3 is 7. So this simplifies to a to the 7th. So let's take a look at why these properties work. The very first one is the product of powers, or I always like to call it the product rule. If we have 6 to the third times 6 squared, this is equal to 6 to the 3 plus 2, or 6 to the fifth. And the reason why, if I have 6 cubed times 6 squared, well, if I group these and expand these exponents out, I have 6 times 6 times 6, that's my 6 cubed, times 6 times 6, that's 6 squared. If I were to multiply all of these together, I have 6 times itself 5 times, which is 6 to the fifth. So let's go ahead and try these without a calculator. H to the 7th times h cubed gives us h to the 7 plus 3. We can add those exponents. We have the same base, which gives us h to the 10th power. 7 to the 4th times 7 to the 8th. Again, we have the same base, so we can do 7 to the 4 plus 8. Add those exponents. We get 7 to the 12th. And finally, we have x cubed y squared times x cubed y to the 6th. Multiplying x's with x's and y's with y's, we get x cubed times y squared times y to the 6th. Well, now we can combine those with like bases. So we have x to the 3 plus 3, y to the 2 plus 6, and we get x to the 6th, y to the 8th. So we can add those exponents of like bases. The second property that we're going to look at is the quotient of powers, or I like to call just the quotient rule. Here we have 6 to the 5th divided by 6 squared is equal to 6 to the 5 minus 2, which is equal to 6 cubed. And the reason why is if I were to expand this out, so 6 to the 5th over 6 squared, in the numerator we would have 6 times itself 5 times, or 6 times 6 times 6 times 6 times 6. In the denominator we would have 6 squared, or 6 times itself 2 times. And then notice we can cancel out a pair or 2 factors of 6's in both the numerator and denominator. All that's left is 3 6's in the numerator, or 6 cubed. So let's try these without a calculator. X to the 15th divided by x to the 11th. We have the same base, so now we can subtract these exponents. X to the 15 minus 11 is x to the 4th. P to the 10th divided by p to the 7th. Again, same base, so we can subtract those powers, those exponents. So 10 minus 7, p to the 10 minus 7 is p cubed, or p to the 3rd. And finally, 25 to the 18 divided by 25 to the 7 is 25 to the 18 minus 7, or 25 to the 11. So yes, this also works with numeric bases as well. Let's take a look at the final property that we'll look at today, which is the power of a power, or I also call it the power rule. So for all real numbers, a, b, and c, if we have a to the b and then raise that to the power c, this is equal to a to the bc, where we multiply the exponents together. So an example, x cubed to the 4th is equal to x to the 3 times 4, or x to the 12th. And the reason why is if we have x cubed raised to the 4th power, that's just like saying x cubed times itself 4 times. That's that raising to the 4th power. So notice what happens here. Now we have our product rule. We're multiplying all of these with the same base. So we can do x to the 3 plus 3 plus 3 plus 3. This is repeated addition or multiplication. So we have x to the 12th. So let's go ahead and try this power rule. R to the 8th raised to the 3rd is equal to r to the 8 times 3, or r to the 24. A squared to the 4th power is equal to a to the 2 times 4, or a to the 8th. This one's a little tricky. We have 4x cubed y to the 5th, and that's all being squared. So let's try this two different ways. We'll try the first way like this, where when we square something, we're just going to multiply it by itself 2 times. So if I were to square this, I would have 4x cubed y to the 5th times 4x cubed y to the 5th. And we're going to multiply those like bases. So 4 times 4 is 16. X to the 3rd times x to the 3rd, well, we have like bases and we're multiplying, so we can add the exponents, is equal to x to the 6th. And likewise, y to the 5th times y to the 5th, we add those exponents of like bases, we get y to the 10th. Another way you can do this is, I'm going to write it over here, so 4x to the 3rd, y to the 5th, all squared. You can take that square and distribute it to every factor. Now, I caution against this. A lot of students forget to multiply the coefficient or distribute the exponent to the coefficient. Remember, that's one of the factors too. So please remember to distribute the exponent to the coefficient as well. So here we would have 4 squared times x cubed squared. And we would have y to the 5th squared. So every factor gets squared. So 4 squared is 16. X to the 3 to the 2 is x to the 6th, and y to the 5th to the 2 is y to the 10th. So notice we get the same answer either way. All right. And now let's take a look at the power of a quotient. So again, for all real numbers a, b, and c, if we raise the quotient of a and b to the power c, then that is equal to a to the power c over b to the power c. We can distribute that exponent to both the numerator and denominator. So an example, 2/5 cubed is equal to 2 cubed over 5 cubed, which let's go ahead and evaluate both of those. 2 cubed is 8, or 2 times 2 times 2. And 5 cubed is 125, or 5 times 5 times 5. The reason this is the case is because if we were to cube 2/5, then that would be equal to 2/5 times itself 3 times. So we have 2/5 times 2/5 times 2/5. And when multiplying fractions, we can just multiply straight across. 2 times 2 times 2 is 8. 5 times 5 times 5 is 125. So we get the same answer. Let's go ahead and try these without a calculator. So here we have x over y to the 10th power. Let's go ahead and distribute that exponent into both the numerator and denominator. We get x to the 10th over y to the 10th. Letter B, we have t divided by 7 all to the 4th power. Again, let's distribute that power of 4 to both the numerator and denominator. We get t to the 4th over 7 to the 4th. And last, letter C, we have 2/3 all to the power 8. This is equal to 2 to the 8th over 3 to the 8th, distributing that power of 8 to both the numerator and denominator. And then let's go ahead and evaluate both of those. Anytime you can evaluate, I would say go ahead and evaluate. 2 to the 8th is 256, and 3 to the 8th is 6,561. Oh, and that reminds me, let's evaluate for letter B as well. We didn't evaluate 7 to the 4th, so let's go ahead and evaluate that. That is 7 times 7 times 7 times 7, which is equal to, well, we have our answer, t to the 4th over 2,401. So there you go. Go ahead and evaluate whenever you can. All right, let's try a few more, and then we'll do some practice. So number 19, We don't have to show any work, but for what value of x would cause this equation to be true? We have q squared times q to the x equals q to the ninth. Now this is our product rule. So what number plus 2 is equal to 9? Remember, we add these exponents. So 2 plus x is equal to 9. Well, then x must be equal to 7. For number 20, we have our quotient rule. So we subtract the exponents. So 11 minus x must be equal to our answer 4. So 11 minus what number is equal to 4? You can solve this. The answer is 7. And finally, this is our power rule. We can distribute that exponent into both the numerator and denominator. We get y to the 6x over z to the 4x is equal to y to the 24 over z to the 16. And then you can ask yourself, well, what number times 6 is equal to 24? And what same number times 4 is equal to 16? The answer, 4. All right. Let's try a few more. Go ahead and flip the page. So here I want to sort each of these problems as a product in the product rule, the quotient rule, the power rule, or a combination of them. There are 3 examples of each, and there are no repeats. So we're going to sort them, and then we're also going to simplify without a calculator. So we'll do a few on our own, and then you'll check your answers at the end. So number 1, we have y to the 4th to the 5th. This here is a power to a power, or the power rule. So let's go ahead and put that here. Y to the 4th to the 5th. And that's equal to y to the 4 times 5, or y to the 20th. Number 2, x cubed times x to the 4th times x squared. This is our product rule. So let's go ahead and sort that here. And for the product rule, we add the powers. So 3 plus 4 plus 2 is equal to 9. So we have x to the 9. Number 3, x to the 8th divided by x cubed. This is our quotient rule. So we subtract the powers. So we have 8 minus 3. And we know 8 minus 3 is 5. So that simplifies to x to the 5th. And we'll do one more together. Number 4, 3x to the 5th, all squared. This is our power rule. So we have 3x to the 5th, and that's all squared. Remember, we distribute that power to every factor, including the coefficient. So we have 3 squared is 9. X to the 5th squared is x to the 10th. All right. So go ahead and sort numbers 5 through 12. You can pause the video and then unpause the video to check your work. All right, here are the answers. So go ahead and take a look. On the left, we have our product rule. Next, we have our quotient rule. Next, we have our power rule. And finally, we have our combinations. Did you get all of them right? Check all of your answers. All right, so that concludes our notes on properties of exponents. Tomorrow we're going to pick up day 2, which includes the negative exponents and the 0 exponent. All right, we'll get a whole lot of practice on this, so we'll see you tomorrow. Have a great day, everybody. Goodbye.